Right, this is going to be the Goldbach Conjecture. It's a pretty old mathematical problem relating to the prime numbers. Prime numbers can only be evenly divided by themselves and 1. Okay, that's the simplest definition I can think of to describe a prime number. We've all heard of the prime numbers. The Riemann hypothesis concerns prime numbers. The Swinnerton-Dyer conjecture uses prime numbers as part of the counting process in some contexts. There's the Goldbach conjecture and twin primes conjecture. All of these four problems, Riemann, Swinnerton-Dyer, Goldbach conjecture and twin primes conjecture, are all written about on protheory.com and my forum, which is linked to from protheory.com, and a lot of my YouTube videos as well. So the Goldbach conjecture basically says every even number greater in size than 2 can be expressed as the sum of 2 primes ad infinitum, which means forever and ever and ever. And that's the basic thing. It's a singular statement, as usual, as all these problems usually are. Every even number can be expressed as the sum of 2 primes if it's greater than 2. That's it, it's a single statement. Every even number. As you know through pro theory, any singular statement also has an opposite and neutral potential. This isn't me being pedantic or annoying on purpose, it's just the way things are in a sense, really. This is the nature of everything. There's 3 things, but there also isn't plus neutral. This is, like I say, that's the answer to the Goldbach conjecture that I've given on my essay on protheory.com and on my forum anyway. So every even number greater than 2 can be expressed as the sum of 2 primes. Every even number greater than 2 cannot be expressed as the sum of 2 primes plus neutral. Like I say before, if you try and prove me wrong, right or neutral, it loops. And that's about all I can say about it, really, I think. I mean, I do find prime numbers extremely interesting, and they're thought to be the building blocks of all the other numbers and all this and all these larger numbers, but to be honest, it comes back to the simple idea that numbers symbolise either one singular, the opposite to 1, which would be not 1, perhaps plural. I'm not going to go too specific with that. So numbers, all numbers symbolise either 1, the opposite to 1, or neutral, which is 0, which is nothing, which isn't 1 or the opposite to 1, it's nothing. It's in between the 2 points, you see. And I mean, I really can't see it any more complicatedly than that, really. Like the Goldbach conjecture, they've tried to prove it with computers, as they have with the Riemann hypothesis as well, the Swinnerton-Dyer conjecture, for example, as well, which is a perfectly natural process to follow. I mean, they're trying to use computers because computers are faster than humans, basically. Essentially speaking, anyway. It's like me having a piece of paper and trying to do a load of calculations, which a computer could be programmed to do in seconds, really, because it's just got the extreme focus. It doesn't think, oh dear, I'm thirsty, hungry, bored, distracted, which a human might do. All of these things might cause a human not to have complete focus at the time of working it out, you see. So basically they're using computers to try and prove, you see, or find a contrary instance. So they're trying to go as high up in a forward sense with the prime numbers as they possibly can. They're still doing it now, by the way, to see if every even number greater than 2 is, or can be, categorically expressed as the sum of 2 primes, you see. So all you do is you just get an extremely large even number, work it out as 2 primes, and work out which numbers are prime, basically. Depending, I mean, we're talking enormous numbers here that only a computer could really sort of comprehend, if that's the right word. I don't think it is, but only computers could really deal with numbers this enormous, because they're difficult to even imagine, really. And that's the process they're using to try and prove, as I say, inverted commas, prove the Goldbach conjecture. Now, a conjecture means something that's not proven, it means a suggestion, really. Pro theory is actually a suggestion, if you look at it that way. I mean, if I said pro theory is a theory of everything, singularly, then that leaves 2 opposite options. Well, 2 options left, the opposite option and the neutral option, you see, because there's 3 potentials within everything. Everything inverted commas again. And like I say, what they're looking for with the Goldbach conjecture is a proof. A proof is a singularity, you see. In this context, they're looking for a single proof, a point at which we can say unchangingly, which is important, a point at which unchangingly we can't go beyond this point. This point won't change. The Goldbach conjecture is true, unchangingly, or false, unchangingly. And they seem to have forgotten about neutral, you see. They've got two opposites, true or false. As we all know, true or false, wrong or right, whatever, left or right. And that's the basic problem, is I really do, I know, so to speak, that there are three potentials within the Goldbach Conjecture. The Goldbach Conjecture is theoretically true, false and neutral simultaneously, in my view and my opinion. This isn't particularly my idea. It's not something I lay claim of possession to particularly. I only claim to say, look, if you really look at it, then you'll see that there is an opposite, theoretically, in your imagination, whatever it is, and there's also neutral potential. So, as I've said with almost every other problem that I've talked about before, even if there was a so-called proof, inverted commas, provided of the Goldbach Conjecture, be it true or false, one of two opposites, we still have to account for the opposite plus the neutral potential in order for us to be accurate. And that's about it, really. It's pretty much as simple as that, hopefully. Hope this comes across right, and that's about it for Goldbach Conjecture. Okay?